one. As you can see, it's the bonus quiz for 1.4. Both of my problems deal with triangles, and I'm going to blow this one up larger here. Now, section 1.4 is where we first really jump into word problems completely. And every chapter herefrom has a section that has word problems in it. So this is a really telling moment in that you want to learn to think with variables. This first problem can actually be solved by playing around, and in fact, that's how I'm going to solve it. And then I'm going to use that technique to actually think with variables and to solve it algebraically. Before I do that, though, I wanted to point out that the last sentence here says find the measures of the angles. And so you would think that we're to find angles of a triangle. But notice the answers here are all equations. And why is that? And that is because of the point I just made, that you could hack the answer here without following the algebraic path. And so forcing you to answer in terms of equations, that's the game afoot here. They want you to think with variables. Now, I've already selected the correct answer here, and we're going to generate this. So let's blow this problem up. Here it is. I'm going to read it aloud. The degree measures of a triangle's angles form three consecutive even integers. Find the three angles. And that should really read, find the equation that generates the three angles. And those three angles are, of course, as it's boxed here, three consecutive even integers. And that's the big point here. The starting point, of course, is the fact that the three angles of a triangle sum to 180 degrees. And A plus B plus C, they must be consecutive even integers. So let me hack my way through this, as maybe many of you did. Here are examples of three consecutive even integers. And I'm pointing out that 0 is considered even. And if I add 2 to it, I get the next even integer. And so 0, 2, and 4 are three consecutive even integers. So too are 10, 12, and 14. And I'm just showing this for effect that, in fact, negative numbers can be considered even integers. And so here are three consecutive negative even integers. Of course, since we're dealing with the angles of a triangle, we know we're not going to have negative integers. Now, seeing this pattern, of course, you might say, well, since three angles must sum to 180, divide this by 3 and I get 60. And I know that then that 60 plus 60 plus 60 will give me 180. And this is in fact a equal angular triangle. Then you could play the game and say, well, look, here's all I need to do to get three consecutive even integers. Subtract 2 from this one to make it 58. And then add that 2 to this one to make it 62. And I would have this situation here. 58 plus 60 plus 62. And of course, that's going to still sum to 180. And those are three consecutive even integers. And these are, in fact, the angles being sought. But again, we're looking for an equation, and we're looking to think in terms of variables, because that's going to be the key to getting these in future chapters. And so let's do that. Now, it's a short step up from here, and this is why this is such a wonderful example to really master if you have trouble thinking with variables. Here is the pattern that captures all consecutive even integers. I'm going to call the first one x. I don't know what it is, but then I know if I add 2 to it, I get the next one up. Notice that you add 2 to this, you get negative 8. You add 2 to this, you get 12. You add 2 to this, you get 2. You add 2 to this, you get 60. So this pattern captures two consecutive even integers. And if I add 2 more to this, I get the third one. Notice you add 2 to this one, you get the third one. 2 to this one, you get the third one. And another way to think about that, you take the first one and you add 4. Add 4 to 0 and you get the third one. And so this captures three consecutive even integers eternally. And the game, of course, here is that they have to sum to 180. And that's the setup. That's the next move, is to simply create the equation. Those three angles must sum to 180. Now let me create some space here. And the situation we have now is what I call plus parentheses. And you should be able to handle plus parentheses without batting an eye. You simply ignore the parentheses. So that looks like this. And then the game becomes one of combining like terms. So I have 3x plus 6 is equal to 180. Now, that's the answer that we saw in MathXL. That's the one I put the circle next to. And that's where we would stop. But you don't have to stop there. You can continue on, as we did in 1.3, and solve this for x by subtracting 6 from both sides to get this, and then dividing both sides by 3. Now 174 divided by 3 gives you 58. And the reason why I'm doing this is to remind you that when you are dealing with these kinds of problems, you really have to be certain you're done. This is the first angle. In the future, they're going to want all the angles, and so you would take your 58 up here, put it here, and then you'd put it here, and you'd add 2 to it to get 60. Then you'd put your 58 here, and you'd add 4 to it to get 62, and you'd have your 3 angles. Here is the situation in MathXL, and this is in fact the correct answer. Let's get on to problem 2.